All right, welcome ladies and gentlemen to week number 40, Open Q&A. My name is Brian McLogan and I am here to answer your questions. And the theme for my live stream this week is how to study for your math exam. Because, I got kind of thinking, we're kind of, in my school, we're kind of on the same schedule, going on for exam schedules. But, I got to thinking that I know a lot of schools and a lot of, everybody's different. And a lot of schools, a lot of districts and countries have changed up not only how they're doing exams, how they're administering exams, but when students are taking exams. And it also kind of dawned on me, like if you had your exams canceled, like I know a lot of schools did, then it's been a really, really long time since you have had to study for a semester exam. Or and a course exam, depending on where you are at in your own curriculum. So one of the things I have, made some videos, and I've talked about this, before, but I wanted to make sure I spent over some times and gave you guys some great tips that you guys can use as you are preparing for your math exams. So, hey, Jay Grat, Ellis, Leon, Linanzi, Ali, Anzi, Caroline, TJ, Jack, good to see you guys. Thank you so much for joining in on the live stream with me tonight. And I do apologize for being a little tardy here, but I just actually got finished doing a free response question review on my channel or in my YouTube memberships thing. So therefore, that's something that I am preparing my students for. I'm going over some tips. I'm going to cover some tips with you guys, obviously tonight. But I also wanted to make sure that you guys were aware that I have a checklist that you can kind of follow. If you want a little bit more information of everything that I've covered here, then you can definitely go. If you go ahead and take a look into the description of this playlist, you'll be able to go and see that there is a link to my checklist for my semester exams. And what you can do from there is just kind of download, it's completely free. And all you can go ahead and take a look at is just kind of like this, step by step. I call it like my plan, prepare, practice, and pass your semester exam. Because, a couple of the tips that I'm going to highlight for you in this live stream is it's not so much like, what exactly you need to study, but it's like, how do you take all this information that you have learned throughout this whole course? And I mean, this year is even more difficult, because we've had so many other things going on, but how are you going to take all of this content that you have been like thrown onto you and really simplify it into a way that you can, be ready for an exam? And that doesn't matter if it's a semester exam or a final exam. I also have another offer for those of you that are taking pre-calculus, because obviously one of my big pushes this year has been turning my pre-calculus curriculum into an online course. And so I've already created a lot of this content for my own students, but one of the things I've also created is this online review. And this is kind of like a mini course. And this is a little bit additional. This is not a free pre-calculus course, because I think I've covered over 450 problems that I have for this mini course. So if you are looking for a little bit benefit, a little extra help in the pre-calculus realm, and you're not already currently enrolled in my pre-calculus online course, then you can definitely go ahead and take a look at that and see if it's the right fit for you. That is one thing that I'm doing some live trainings for. I'm going to be doing them starting next Sunday. I'll be doing some live trainings, kind of like what we do now, these open Q&As. And basically what I'll do is I'll be available for you and just answer your questions, whatever you guys have for your semester exam. And the cool thing about that is I'm doing it for the semester exam as well as for the end of course exams, because I know that, no matter, like, who knows what's going to happen in the end of course, where everything is kind of going. But that are some things. Those are all that information is in the description if that is of interest to you. Again, I have a free checklist that is for anybody that wants to take a look at some tips and tricks that I've created for you guys. And then also some additional resources, for those of you that are taking pre-calculus. Okay. And so, yeah, so let's go and talk about what are some tips that we can all take away from being on this live stream? Because again, I appreciate you guys all joining in and looking in for some tips. And I'll get to the questions that have been submitted to me up to this point so far. So a couple of things that I would say, when you're looking into the information that you've had, I think the most important thing is to be consistent, to start planning. I know a lot of people have some quizzes. I gave a poll on my channel earlier this week, and a lot of people have their exams coming up this week. A couple of people have them coming up in, 2 weeks into December, maybe into January. And I think the main thing is if you have, however much time you have, try to break it down into, either 4 days or, 2 weeks, but try to be consistent and do something every single day. And obviously, the longer time period you have, the less you really need to spend focusing on doing all, like if you have like 2 weeks, you don't need to spend 4 hours every night, studying for your exam. But I really think it's important to be consistent. And I think it's also important to be able to be consistent and of doing something being consistent and also being focused on knowing what it is exactly you need to study. So here are some tips what I have found when I was studying for my exam. I think the best and easiest thing to study is what you already have. You don't really need to go out there and look for additional problems. Now, again, like obviously on my online course, like I think it is helpful to always be practicing, more problems, and that's going to get into something I'll talk about later. But I think from the starting point, you should just look at your notes. Look at your notes, look at your tests, look at your quizzes. Look at all the problems that you've already done. And I think it's really important to also look at, to reflect on when you got things wrong, because it's helpful when you look at like, maybe like your first chapter test, and you look at it now and you're like, oh, why did I get that wrong? And then you look at this now and you're like, oh, I totally understand how to do that now. Like I was an idiot, so as you progress through the class, obviously things start to connect a little bit more, and you don't really maybe need to practice more of those examples that you now understand, where maybe you kind of struggled at the beginning of the year. However, as you're looking back into that previous content, you might also remember like, oh, I actually never understood that, or I still don't understand that. However, now that you understand more content throughout the year, hopefully as you go back and try to relearn some of that content you struggled with, you have a little bit better foundation that is going to allow you to understand and work through those problems. I think it's also helpful to have, when you have like your notes, your tests and your quizzes, is to redo those problems, because you already have the answers provided for you. That's the best work that you want to do. I think it's always helpful to have answers. Like some of the problems in my course, I have just the answers. And then some of them I have worked out solutions. I think when you have the worked out solutions, if it's your own notes, if it's your own test or quizzes, to like cover up your work and redo those problems, make sure you go back through the process of doing the math, because obviously just doing random problems, if you don't know the answer, if you can't check your work, there's really no point of just going through doing math problems. You want to make sure you're doing it correctly. And especially if it's something that you struggle with, I think it's really important to, cover up the correct solution, try to do the problem on your own. And when you get stuck, you can just unveil, your paper and look at, oh, that's what I got to do. Or that's where I made my mistake. Cover it back up and try to do the problem again. And you keep on doing that until you get the problem correct. That was something that I vividly remember as a student, struggling with my math. And I had to keep on doing that over some of these problems. I remember doing like 3 or 4 times until it finally clicked. And that was just my problem with math. It just sometimes would take me a lot longer for math problems to click. So I had to do them over and over for myself. Now, going into doing what you already have, I think that's the foundation. That's where you should all start. I think another tip that I think would be beneficial for you is to take all the content information, like for instance, on that chapter 1, let's say you already know how to do some of those problems, but maybe there's some things that you kind of forgot, or you're like, these are really important. I need to remember these. Well, take away some of those most important concepts and put them all together in a kind of a cheat sheet. Sometimes you can kind of draw little lines, like a little web, and like connect them. Or other times it's just putting them all on a sheet of paper. And I think that's very helpful for you to just to kind of like collect things in your brain, and for your brain to make these connections of all this information, all these formulas, these processes, all this stuff that you've done, and try to like condense it onto a sheet of paper. And the thing I like about doing the cheat sheet the best is, as you're going through getting closer and closer to your exam, you're not going to have time to spend an hour doing math problems, right? You've probably already done an hour worth of math problems. So what you're going to want to do is just kind of quickly review as much content as you can rather quickly. Sometimes you might only have like 15 minutes, or you don't want to spend more than 15 minutes studying for exam. So if you've taken the time to create that cheat sheet and you have all this content on this one or multiple sheets of paper, then you can just spend a quick 15 minutes reviewing the concepts, reviewing the formulas and theorems that you have covered rather quickly, rather than shifting through all of your notes and flipping through all the papers. And then the last kind of just general tip, again, I go into more details on all of this in my checklist that is in the description below. But just another tip I'd just say is just, practice. I think the main thing is people will do a problem. They're like, okay, I got it. And I think my favorite quote that I get from students is, oh yeah, like the teacher does the easy problems and then gives the hard problems on the quiz, right? And I'll joke with my students on that as well. It's like, all right, guys, here I'm going to do the easy problems and then I'll give you guys the hard problem later in the test. And, it's kind of like that joke. And, and sometimes that does end up being true. But a lot of times I try to cover the hard problem and then, they'll see the easier problem on a test or a quiz. Like it's not always the truth. I'm not always that guy. But I think the important thing for you to take away from this is, just because you understand how to do one problem doesn't mean that you're going to understand how to do a variation of that problem. And, that's why a lot of times we can't do every single type of problem. It's impossible to be able to do that in a class, right? Especially if you're teaching from on there. So, teachers have to make decisions. And, I always want to provide my students with as many examples as possible. But still, even providing them with multiple examples, there's still going to be problems where you're going to want to see, do they know what they're doing? And, by changing the problem a little bit, you can be able to see through their thinking and through their approach if they really understand the concepts. Or sometimes just changing something a little bit can completely confuse somebody. So I think it's important that when you're going through and preparing through the problems, just don't focus on the easy problems. You're like, oh, I know how to do this. Like, try to look through your book or, look through different variations of that problem to see if there's something that's similar, but maybe is more confusing or that you would need to think about that you've never seen before. Because again, on an exam, it's go time. You got to be able to approach those problems and solve them rather quickly. You don't have much time to, be, thinking and especially on a multiple choice, depending on, on that, but you're not going to have a lot of time to be, creating some new thoughts. It's like, hey, I need to know my approach and I need to get after it. Right. So there's some points for you guys. Hopefully you can take away from that live stream if you don't want my checklist or if you don't want to join my pre-calculus exam course. But so hopefully that was beneficial for you guys. I think that I think it's very difficult for this year as far as the kind of instruction has gone. I heard some people had their exams canceled and there's a part of me that's like, yeah, that's just, with everything that's going on in the world, I totally get it. There's also a part of me, that also says I also want to give my students the same experience that they kind of deserve. And not to just to change things up, make sure we kind of hold people to a same kind of standard. And it's a little bit of that tug and pull. I want to make sure that they have the same rigor that not so much because I want to give them rigor, but because I want to make sure that they, get that. Because to be honest with you, if they're learning, I want them to feel like they deserve that impact of that learning of what I need them to learn and not just giving them all the grades, even though I know everybody would love just giving grades. Right. But yeah, there's this kind of, we got to be understanding of this current situation and climate that we're dealing with as far as exams and as far as grades. But also in the same respect, I think it's important to try to come back and deal with some kind of normalcy. And making sure that, students are understanding the information they need to understand before moving on. Because obviously, as far as pre-calculus goes, if you're not just learning pre-calculus, just to learn pre-calculus, there's typically the next level that you are planning to go into. So there you go, ladies and gentlemen. That is my little spiel. Hopefully that, again, was helpful for you. And I see you, Nicholas, Alexis, Windingo, and Declan, Vivian, AJ. Thank you so much, guys, for joining in. Let's go and get on to some math questions. And Addie, thank you so much for, again, joining in. And Addie, I did see your questions before, and I just didn't have time to respond back into them. But yeah, I totally agree. I mean, to be honest with you, a lot of your points. The one thing I would counter with your points a little bit is, obviously, as you know, there's a lot of stuff that you learn that's not going to be applied to real life. I don't think the point of what we're learning in mathematics, or really in anything in school, is always to be applicable to everything being in real life. But, so I think that that's not as far as our goal into everything. But you did bring up some, points and some issues with, not, dealing with a lot of the stuff that we still test on, as far as exams, and that we're still teaching, that, why are we learning this? And I think that's a really great question, and I don't think it needs to be like, how does this refer to real life scenario? Because a lot of things we learn don't need to necessarily have a direct connection to real life. But a lot of things we need to learn is like, why are we learning this? There's still a lot of stuff that I teach inside of my curriculum because it's technically just on the exam. But besides that, it's like, why am I teaching this to my students? Why do I want them to know this stuff? And, there's definitely some content that I'm like, there's a lot more beneficial things I'd rather be teaching them that is going to help them out. And they can learn this other stuff later if they really want to study it, or if it's just outdated, it's not necessary, it's cool, maybe, right? It'll help them maybe make some connections, but that's really about it. So I think you brought up some great points and some questions, and I'm hoping that through, one of the silver linings with this COVID and situation with the impact on education is that's going to be a conversation that we're going to continue having. Like, why are we teaching students what we were teaching them? Why do students need to know the double angle formula, right? And obviously going into a calculus world, that's going to be something important, right? But do we want everybody to understand the double angle formula of these triangles? Or, what are we kind of looking for? So either way, I could literally probably talk to you guys for the rest of the night about my views on education. So let's go ahead and get into these questions. I only have 10 of them, guys. I do apologize. We'll kind of see how long this takes. I had to get prepared for, as I mentioned, that other live stream that I had going on on the YouTube membership side, as well as in my course. So I did the free response and it took me a lot longer. So thankfully I did some of these questions before I went live. So I got these prepared, but yeah, I think there's like maybe 15 more questions that you guys submitted that I wasn't able to get to. So I do apologize. We'll see how long this talk goes for, and then we'll go from there. All right. So it says for questions 1 and 2, use the fact that pi halves to pi and the cosine of theta equals -5/3, solve sine of theta, solve sine of 2 theta. And then they gave us sine of 2 theta. That's cool. So what we need to do is we need to find our angle here. Okay, so we have pi halves. That's going to be right there. And then we have pi. And that's going to be -5/13. So again, remember cosine is adjacent over hypotenuse, right? Okay, so that's going to be -5/13 because hypotenuse is never going to be negative. Hopefully you recognize this is a Pythagorean triple. And so therefore this side length is going to be 12, right? So you could use the Pythagorean theorem if you wanted to, but hopefully you know that that's a second quadrant. That has to be positive. All right, so the double angle formula. So it just says, so first thing you want to do is find the triangle, which we created. Because again, that's what the trigonometric functions are, right? They are comparisons of the sides of a triangle. How big is one side compared to another side based on a given angle, which in this case is theta. So all we're simply going to do for the sine of 2 theta is do 2 times the sine of theta. Well, the sine of theta is opposite over hypotenuse. So that's going to be 12/13. And the cosine of theta is adjacent over hypotenuse. So that's going to be -5/13. And then we're just going to simplify. So 12 times -5 is going to be a -60 times 2. So it'd be a -120 divided by 13. Okay, so for the half angle formula, it's going to be the exact same process. But to make sure that I can get through everything, I'm only going to solve one problem for people on their submission. But yeah, you just do the same thing for the half angle formula. I can't remember what it is, but you just plug in your sine and your cosine value, or at least just maybe the cosine value, I think, for that. All right, Lexi brought in a great question. I love this question because she went ahead and solved her quadratic. So she had a good old factoring problem, 20y squared minus 34y plus 6. And this is actually something we're doing in our class. And again, it's like, why are we teaching students how to do this kind of stuff if they don't really understand what they're doing, right? And I have nothing against Lexi because I have the same thing. Like, I had to make some decisions on my classroom. Like, how do I want to teach this? I can teach them so they can do it, but I also want to know why are they learning this? Why do I want them to learn this? Because in pre-calculus and calculus, we don't do many problems that are like that. All right. So in this case, she goes ahead and solves it using the AC method, where you multiply A times C, and then you add them to find your B. And then she did grouping. And what she found out is when she changed the middle terms, their order, she got different answers. But in reality, she didn't get different answers. Because what's the cool thing, Lexi, is here's answer 1, answer 2. But notice how answer 1 has a common factor of 2. So if you factor out a 2, you get a 2y minus 3 times a 5y minus 1. And over here, again, you can factor out a 2. When you factor out a 2, you get a 5y minus 1 times a 2y minus 3. So Lexi, the answer to your question is it doesn't matter. You did it correct. Just pick one way and roll with it. Okay? Just make sure you factor it down all the way, and you'll see you'll get the exact same answers. Okay? But thank you for that great question, because I love that as a teaching tool for students. I thought that was great. All right. I did this as a question 2, number 3, because I went to go and copy down, and then I realized, oh, a lot of times students will submit a picture, and I'm like, okay, great. And then students, will just say, I said, what do you guys want me to help you with? And then student writes polynomials. Well, guys, I spend 2 weeks teaching polynomials in Algebra 2 and in pre-calculus. So I have no idea what that student wants. And you can see when you submit your questions, be very specific. Okay. So either provide a picture or be very specific on what it is you actually have a question on or you need help with. And that just helps me provide you guys the most amount of value when we're doing these live streams together. The next question was so this student got a little bit better, right? So that's why I decided to go through it. So I'm having trouble with finding the angular and linear speed of an object to process. Seems simple, and it is scaring me. Well, doesn't need to be a scare you, but yeah, it is basically simple. If you think about a circle, we have theta, right, which represents the angle, and then you have s, which represents the arc length. So to find the arc length, you're just going to take the radius times theta. So when you have theta, which is going to be that measure of rotation in radians, the angular speed is just going to be the change in theta compared to time, right? So again, when we're dealing with speed, right, we're looking for that change in distance over time. Well, angular speed is not really going to be change in distance, but it's going to be change in the angle with referring to time. When we're dealing with the linear speed, what that is going to be dealing with, that's going to be the distance. So that is going to be like a distance, but that's going to be a distance along the arc. So that's going to be your arc length, which is s divided by time. So again, s equals r times theta divided by time. So that's basically the difference. Angular speed, if you can just think of angular speed, think of angle. Theta is an angle. Again, make sure it's in radians. So it's angle with respect to time. And then linear speed, think of that as just going to be going around the arc length. Okay. So hopefully that was helpful for you. Question number 4 says admission to a carnival is $4 for children and $6 for adults. I really don't like doing word problems, but the student submitted 5 questions to me, so I figured I would just do at least the word problem for them. And this one seemed fairly simple enough to at least to be able to create. It wasn't like a big paragraph. Sometimes I get these huge paragraphs. I'm like, I don't even have time to read through this from there. But I did like the final question. It said, what is the ratio of children to adults? So I thought that was kind of interesting. So we'll go from there. All right, so the first thing you do, we need to create some variables. So let's say C is for children, and then let's do A is for adults. Okay, so it says $4 for children and $6 for adults. So however many adults we are admitting, that's going to be $6, and then for however many children, it's going to be $4, right? So again, notice that that's a relationship. So 4 times the number of children, okay, 6 times the number of adults. So it says a group of 21. Now, again, we don't know what's in that 21. So that could be, 20 children and 1 adult. That could be 20 adults and 1 child. But we know there's a total of 21. So my first equation is C plus A equals 21. And it's important when you are doing a systems of equations, when you have 2 variables, you're going to be looking for 2 different equations, right? If you have 3 variables, you're going to look for 3 different equations. Then the other one says that you have a group of 21 that pays $90. Okay, well, so now we have some monetary that's value here. So we have this $90 in admission for the carnival. So we know that if there was 1 adult, that'd be $6. 2 adults would be 12. 3 would be 18. I can write a relationship for that. I can say 6C, right? So $6 times the number of, no, sorry, that's children, right? That's $4. Oops. $4 times the number of children. Come on. And then plus, this would be 6 times A. And then $6 times the number of adults. And that's going to equal 90. Okay, so now we have a system of equations. We have our two variables, C and A. Now we just need to solve. So you could use substitution. You could use elimination. But that is going to be our main thing. Thank you. All right, so now what we're simply going to do is I'm going to use elimination. So I'm going to rewrite this. C plus A equals 21. And then I have 4C plus 6A equals 90. Okay, so what I'm going to do is I'm going to multiply the top equation. Come on. I'll multiply this top equation. What am I trying to do? Multiply the top equation by a, let's get rid of the negative 4. You can do it by anything, but let's multiply by negative 4. So when doing that, I get a negative 4C minus 4A equals negative 4 times 21. That'd be 42. That's going to be negative 88. Right? 42, 40, 42, negative 40, 84. Right? That's 42. That'd be 84. Okay. And then that would be a 4C plus 6A equals 90. Okay, now what I've done is now by multiplying by that scalar, now what I've done is create a system of equations where I have a coefficient with one's negative, one's positive. If I add those two equations, that's going to eliminate my variable C because that's 0C. This becomes a 2A is equal to 6. So I have 2A is equal to 6, divide by 2, divide by 2. A is equal to 3. So that means there's going to be 3 adults. Okay, and now to find the number of children, all I'm going to do is just replace 3 in for my A. So let's say C plus 3 equals 21. So therefore I subtract 3, C is equal to 18. So again, it says, so again, there are, you could say there are, 3 adults and 18 children. But again, that's not what the question was, right? The question is, what is the ratio of number of children to the adults? So we could say the ratio, not ration, the ratio is going to be 3 to 18, okay? Or you could write the ratio as, 3 is to 18, which could be also rewritten as 3 is to 6, or 1 is to 6. So just a couple different ways you can go ahead and write those ratios. All right, this next question was brought to you by Angelina, and she was asking to identify the domain and the range of our piecewise functions. Okay, so when graphing piecewise functions, remember guys, piecewise functions is just a combination of 2 or more functions. So, and again, you have to have your domain restrictions. So you're going to graph your function, right? And then you're only going to restrict that function based on this domain. So you're going to graph x squared minus 1. So let's graph x squared minus 1. So if I was going to graph that, actually, what I'll do is, so there's x squared minus 1. All right. Now let's graph 2x minus 1. So there's minus 1 and then up 2 over 1. So I could do something like that. And then I could go down like that direction. Now, I think you would agree that that is not a function, right? This is not a function because this does not pass the vertical line test. So this is what the domain functions are all about. What the domain functions are all about here is that this says only graph x squared minus 1 for x values that are less than or equal to 0. So everything to the right of 0, I'm not going to graph. That's where I'm going to erase it. Then this says only graph 2x minus 1 for x values that are greater than 0. So then everything to the left of 0, I'm going to erase. Now, it's interesting that it only says greater than 0, not greater than or equal to. So I'm going to do an open circle. But notice, since my open circle has already been filled in by over here, it's still going to be defined. Then you're going to keep on going all the way to 5. Well, how far is that, right, to 5? Well, 1, 2, 3, 4, 5. Well, when I go up to 5, that's greater than or equal to. If you were to plug in 5 in for x, that'd be 2 times 5 is 10 minus 1 is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we're going to go all the way to there. And then again, that's going to be an open or a closed circle, I'm sorry. There you go. And then here, this is going to be from x values that are only 3. So that's going to be a horizontal line. So if you did into 3, That'd be your horizontal line, right? But it says only for x values greater than 5. So 1, 2, 3, 4, 5. So that'd be an open circle, and then with a y value of 3. So it looks something like that. So everything to the left of 5, you would erase. And there you go. There's your lovely, beautiful piecewise function. Now, it's funny. I got this question. I'm like, all right, usually, piecewise functions is kind of common. You usually get one of those every Q&A. But then the next question was literally from Mari, a completely different problem, like different worksheet they gave me. And again, another graphing domain. So I was like, you know what? Let's just go ahead and do this again. This is great. So same kind of thing. Let's just practice. Maybe we'll do this a little bit quicker here. So I have 2x plus 3 and x is less than or equal to, or less than 1. So this is going to be, again, another linear equation. So I have 2x plus 3, so 1, 2, 3. So up 2 to the right 1, and down 2 to the left 1. Okay, but this is only going to be true for x values that are less than -1. So that's actually going to be an open circle. So we down 2 to the left 1. That's going to be an open circle, and then your slope is going to look like this, right? But we're only going to go to the left. So I'm going to erase all that. All right. And then we have the absolute value of x minus 5. Now that's only going to be true for x values between -1 and 2. So remember that graph is going to be down 5. So 1, 2, 3, 4, 5. And that's going to be the V-shaped graph, right? So it'd be up 1 over 1. That's going to be equal to. And then up 1 over 1, but it looks like it's going to go to 2, right? So then we can go up 1 over 1 one more time. And that's going to be less than 2, though. So that's going to be an open circle. So it's going to be closed. Oh, no, why do you do that? So it's going to be a closed circle here, and then open circle there. All right. And again, just a relationship for the absolute values: over 1, up 1, over 1, up 1, over 1, up 1. They both have a positive slope and a negative slope, because you can see obviously there's no stretch or compression there. And then we have our final one, which is 1, and that's going to be for x values that are greater than 3. So that one's a little interesting. So now we're going to go over to 3, and then we'll go to 1, and that's going to be greater than 1. So there's a big gap between one function and the next, but that's okay. So this one is, they both share at -1, but that's defined. That one's not defined. And then there's nothing between 2 and 3, and there it goes from there. Oh, I forgot to do the domain range, right? Sorry about that, Angelina. So let's go and talk about the domain. So my domain here is going to be all real numbers. Because even though we have a discontinuity here, the function is defined at 5, right? It's defined up here. You can see it's x is less than or equal to 5. And then this is x is greater than 5. The range is going to be how low the graph goes, which looks like it goes down to -1. Oops, so it's defined at -1. And then it's going to go all the way up to infinity. Even though we have a discontinuity here, you can see the graph is defined. Over here, let's go and take a look at this domain. Here my domain is going to be from -infinity to +infinity. But we got to look at our discontinuities, right? So even though I have a discontinuity here, my function is defined, so we're good there. So my domain is how far left does the graph go, which is all the way to -infinity. And then even though it's undefined here, it's defined there. But it doesn't look like it's defined at 2. So it's going to stop at 2. And then it's not going to start back up until 3. Now 3 is defined though, so I should actually use a bracket. And then that's going to go to infinity. As far as my range goes, that's going to be how low the graph goes. This goes all the way down to -infinity. So that'd be -infinity. It's going to go up. That's undefined there, but it's defined there. Undefined there, but that's at 1, right? Yeah, so it's even at 1. Then I think that's good. Yeah, that's going to be the highest value there is at 1. So 2, 1, which is defined there. So my graph's not great, but yeah, that was supposed to be at 1. All right, so there's your domain range. Question number 7 says, consider the function f of x. What are the values a or b that makes the function continuous everywhere? Find the values a and b. All right. So in this case, we know if the function is going to be continuous, right? So if you look at these piecewise functions, you can see these are discontinuous, right? Now, if they were going to be continuous, that where they're separated would be equal to each other. So what we're going to want to do is we're going to say, well, if these are continuous, they would be continuous at -2 and at +2. So what I can do is I can write this equation. I can say, all right, 3x squared would be equal to b plus ax cubed. If these, see, these are your two equations. If these are equal, then those two output values would be equal to each other, right? Just like those would be equal to each other. As well as b plus ax cubed would have to equal x minus 2, right? That output value, again, would have to equal that one. Now, where are they going to be equal to? Well, they have one discontinuity here, one discontinuity there. One discontinuity at -2 and the other one at +2. So what you're going to do is those are going to be the values for x. So you can do 3 times -1 squared equals b plus a times -1 cubed. So -1 squared is 1, so that's 3 equals b plus -1 cubed is a -1. -1 times a is a negative a. So let's do this as b minus a. And then over here we can plug in 2. So I can say b plus a times 2 cubed equals 2 minus 2. Well, 2 minus 2 is going to be 0, so b is equal to an 8. Oops, b plus 8a. Okay, cool. So now we kind of have what we did before. We have a systems of equations. We have 3 equals b minus a. And then over here we have b is equal to an 8a. I'm sorry, why do I keep on writing that, doing that? This is b plus 8a. Okay, so in this case, what I'm actually going to do is I'm actually going to use substitution. So I'm going to subtract an 8a. And I'm going to say b is equal to a -8a. So now I can replace my b with the -8a. So I can say 3 is equal to, instead of b, I'll say -8a minus a. So 3 equals a -9a, divide by 9, -9, divide by -9, a is equal to a -1/3. Now, if I know what a is, so that would be my value for a, and then if I want to find what b is, I would just say, all right, well then, 3 equals b minus a -1/3. So therefore, I'll just write over here, 3 equals b minus a -1/3. 3 equals a b plus 1/3, right? And then if you subtract a 1/3, let's see, you can rewrite that in terms of a 9/3, right? So I could say 9/3 minus 1/3 equals b. So therefore that'd be an 8/3 equals b. So there you go. There's your b and there's your a that makes this function continuous. All right, so the next one says determine the general solution. So this student got through, I can't remember how far their work went, but they set the equation equal to 0, which was good. And then they went and solved, right? Now again, from this point, what we're going to do is we're going to look at the values that are going to make the, what are the solutions? What are the values that make this true? So you can think about this in terms of the unit circle, or you can think about this in terms of a graph. If you're looking at the general solution, that's going to be the values that are unrestricted. So if you know of a graph, if you look at cosine, you're thinking, oh, when is cosine of x equal to 0? Like when are all these x-intercepts happening? Well, it might be hard to kind of visualize the graph, so maybe let's kind of look at the unit circle. Stop, man. So if we go and look at the unit circle in this problem, say when is cosine equal to 0? Well, if here's a perfect circle, which is not, we know that, these coordinate points here, this is 1, 0. Well, that's x, cosine's x, right? So you could say, oh, this is 0, 1. You can say, oh, okay, it's going to be at pi halves and then at 3 pi halves. So this is going to equal to 0 at x equals pi halves plus, now how far is it from pi halves to 3 pi halves? Because if I add pi again, that's going to take me back to another solution. So that's going to be pi halves plus pi n. And again, n can represent a positive or a negative integer. But if you keep on adding pi or subtracting pi, it's going to keep on taking you to these two values where cosine is going to equal -1. Now for the next value, it's going to be sine of x is equal to +1. Well, when is sine of x equal to 1? That's going to be, again, at pi halves. So, and that's going to be at x equals pi halves plus 2 pi n. Because the only time y coordinate's going to be 1 is up here. And you could add 2 pi, keep on going around. Well, that already happens once. So we already have that solution. So since cosine happens more frequently, and it includes the solutions for sine of x, I'll just say x equals pi halves plus pi n. All right. Did I get to number 10? Oh, I did. Okay. So the next one was find the numbers of sides of a regular polygon given the interior angle and then the exterior angle. So these are some geometry and geometry questions that I had to write down the equations because I'm like, even though I'm teaching geometry right now, we haven't got to this yet, and I don't remember. It's been over 10 years since I taught geometry. So I did not remember these formulas, but I did remember that there were formulas. I just needed to look them up again. So the important thing that's going on here is this is a regular polygon. And if you remember, regular polygon means that all the angles and sides are going to be equal in measure. That's important because if I want to figure out the sum of the interior angles of a regular polygon, all I need to do is be able to take my number of sides, my 144, and multiply that by my number of sides. So 144 times, so n equals the number of sides. Now in this case, we don't know. They're asking us what is the number of sides, but I know that the sum of interior angles is the interior angle times the number of sides. So this equals the sum of all the interior angles. So that's important. So the interior angle times the number of sides equals the sum of interior angles. So if I want to go ahead and solve now for the number of sides given one interior angle, I can say S equals 144n. So I can say 144n is equal to, I can distribute here, 180n minus 360. Okay, so I can add 360 to the other side and subtract 144n. And therefore I have 360 equals, and let's see, that's going to be a 36n. Well, this is nice. Divide by 36, divide by 36, n is equal to 10. And then for the other equation, it says for x, all you need to know for the number of sides when you have an exterior angle is just take 360 divided by the exterior angles. That will give you the number of sides. Okay, so that's all you got to remember. So this is n equals 360 divided by 24. And actually, I don't remember doing that, so I'll just do that real quick. 360 divided by 24, 15. I should have done that. So n is going to equal 15. So there's your two examples. Here's another one. I was just laughing at these. I'm like, what do you want me to do from these? I mean, there's just so many examples I could cover for you. So again, if you have a question on trig identities, just try to be as detailed as you guys possibly can. All right, but so this one is again another picture of an equation. So this one says solve sine squared of w equals -4 cosine w for all values. Okay, so first thing I notice is when I want to solve a trigonometric equation, typically I'm going to want to solve them in the same terms, like sines and sines and cosines and cosines. So what I'm going to do here is I'm going to rewrite this as my trigonometric function. So I'll say sine squared, or remember, I recognize the squared as my Pythagorean relationship. Cosine squared w equals 1. Okay, so if I wanted to replace it, if I already have a cosine here and I want to write this in terms of cosine, then what I'll do is I'll subtract the sine. So I have a cosine squared w equals 1 minus sine squared w. So now what I have here is I write 1 minus sine squared w equals a -4 cosine of w. Now again, we recognize, oops, I'm sorry. That's a, what did I solve for cosine? I'm an idiot. I need to solve for sine. So you subtract the cosine squared. Okay, so I have a sine squared w equals 1 minus cosine squared w. All right, so that is going to be a cosine. cosine squared W. All right, so now we have a quadratic, so we know we need to set this equal to 0. Now again, remember for quadratics, we're going to be looking for solving this either by the quadratic formula or by factoring. So hopefully this is factorable, but when I get these over to the same side and write them in my standard form, plus 1, I see that this is non-factorable. So therefore, I'm going to need to use the quadratic formula. Now, again, when we're looking into doing the quadratic formula, we're just going to look into, like, we want to kind of forget about the cosine trigonometric functions for a second and just realize we need to be able to find these solutions for x. Like, forget about if these were, the cosines of these variables or not. We just want to be able to solve for x using the quadratic formula, and then what we're going to do is we're going to take the cosine of our angles or the inverse cosine of those to solve for our solutions. Or like my point that I'm trying to make is we're going to solve for w, but remember we're not really solving for w because the question here is the cosine of w. All right. Now the first thing I'm going to do is just divide everything by negative. So that would give me a cosine squared of w minus 4 cosine w minus 1. Equals 0. Okay, so let's just pretend this was x squared. Let's just make this math a little bit easier. X squared minus 4x minus 1 equals 0. Okay, because the nice thing is, let x equal the cosine of w. Okay, just let x equal the cosine of w. Let's do the Pythagorean theorem here. So if I needed to solve this, or Pythagorean theorem, the quadratic formula, if I was going to solve this, I'd have x equals opposite of b plus or minus the square root of negative 4 squared minus 4 times a times c all over 2 times a. 4 plus or minus, let's see, that's going to be a 16, and that's going to be plus 4 divided by 2. 4 plus or minus, let's see, that's going to be a 20 divided by 2, square root of 20, guys. That can be rewritten as the square root of 2 times 5. So 4 plus or minus, that would be 2 times the square root of 5, all over 2. Divide the 2 into both of those. X equals 2 plus or minus the square root of 5. Okay, but again, remember, I only did this math to make this a little bit easier. X still represents the cosine of w here. So now I can say cosine w is equal to 2 plus or minus the square root of 5. So cosine w equals 2 plus the square root of 5. And cosine w equals 2 minus the square root of 5. Okay, so now what you're going to need to do is go ahead and use the inverse of this. And I'm not going to type this in for my calculator, but w is going to equal the cosine inverse of 2 plus the square root of 5. And w equals the cosine inverse of 2 minus the square root of 5. And there you go, ladies and gentlemen. That is at least 10 questions. I feel comfortable. I feel good with doing. Actually, you know what? Let's just do this. What do we want to do our angles in? Does it say? Between 0 and 2 pi. So we're going to use our radians. So actually, you know what? I'll just do this for the student. Why not? That'd be the nice thing to do, right? All right, we're in radian mode. So I'll do cosine inverse of 2 plus the square root of 5. Uh-oh, that's not right. Okay, and so 2 minus the square root of 5 then. So I can do the cosine inverse of that. Okay, so therefore that's going to be w equals, that does not exist. That is not within my domain because, yeah, it's going to be larger than 1. But this is going to be 1.809. And there you go from there. So hopefully that was helpful for you guys. Again, if you are looking for some exam checklist review to get help with your upcoming semester exam, I do have a generic exam or checklist that you guys can go ahead and download for free. It's in description below that you guys can go ahead and download. And then also for those of you that are taking pre-calculus, if you are looking for a little bit more of a premium experience to get prepared for your pre-calculus exams, I do have a pre-calculus mini course that I'm offering as well for those of you students that are looking for a little bit more help getting prepared for your pre-calculus. But otherwise, guys, that is it. I'm not taking any more questions, guys. I do apologize for that, but I have been going live teaching since 7:30, I think, actually today. So I'm exhausted and I have to go to school tomorrow and do some more teaching. But I do see your question, Ralph. I do not do any tutoring during Zoom. My schedule is pretty much completely full, guys, with doing YouTube as well as teaching inside of the classroom. So unfortunately, I do not have any private tutoring, but a couple things I do. I do go live here, guys, on this channel every Sunday night at 9 p.m. There was 15 of you that submitted questions that I did not get to, and I do apologize. You will be the first 15 questions I get to tomorrow or for next week. So, but you guys can always submit your questions. I do have those, the form in the description below. So if you guys do have a question coming up, feel free to submit it into the Google form. The more descriptive and specific you are, the more likely I'm going to answer it on the live stream. I am not a genius though, so I don't know the answers to every question, but feel free to always submit something and I'll do my best to help you guys out. But in addition to answering your questions every Sunday night, I do also have a private live stream inside of my Google or my YouTube membership that we do an extra live stream from there, which I was planning on doing it once a month, but sometimes we actually kind of go by a little bit more often than that. So I've been experimenting with that, and hopefully that has been helpful for all of you guys that are part of the memberships, which I really, really do appreciate all of your guys' support. So I know a lot of questions, guys, keep on getting submitted in. Please get those into the Google Forms, guys. I apologize. I used to do them in real time and it became way too difficult to answer your questions, or to keep on taking them from you guys as we're going into real time. So, but otherwise, guys, hopefully you are having a great start to your week. Hopefully, if you've already taken your exam, you did a great job. And if you have your exam coming up this week or in the next couple of weeks, keep on studying hard. Just put in the work. I know it's not fun. I know a lot of it's probably the last thing you want to do. But you know what? The nice thing about the exam is you do all that hard work, you put in all that effort, and then boom, you're done with it. And then it's time to move on, right? Into the next semester or into the next content, next chapter, so on and so forth. So put in the work. It's not the most fun thing to do or always the easiest, but put in the work, study hard, relax, do the best you can do. And that's all we can ever ask of you. All right, guys, hope you have a great night. And I look forward to seeing you guys on next week for another live Q&A. All right, guys, cheers.